Okay, hello everyone. Today we're going to solve linear systems using substitution. Remember the last lesson we used graphing to solve it. Again, we're looking for the intersection, and we're going to use a technique called substitution, which you've used something like this before. Today's objective, to solve the systems of linear equations using substitution. The essential question, again, how can we use substitution to solve a system of two linear equations? Just a quick review. Guys, a linear equation looks like this. Y equals 2x plus 5. That's slope-intercept form. Or it might look like this. 3x plus 8y equals 7. That's standard form. The key is, though, it's just y and x. And when you graph it, you get a straight line. Okay, you have a constant slope. That's the key to linear. Something that's nonlinear will look like this. It'll say like x squared, or it might say x to the third and y squared. It might say, that's not linear. Those are not straight lines. Okay? Now, substitution is simply replacing a variable in one equation with its equivalent expression. As an example here, if y equals 2x minus 7 and y equals negative 4x plus 11, well, we can make these two things equal to each other. They both equal y. So I can just substitute 2x minus 7 in right there for y. And say 2x minus 7 equals negative 4x plus 11, okay? And once we do that, now we only have one variable, x. We've eliminated a variable using substitution. So now we can solve that for x. All right? Once we do that, then we plug it back in to find out what y is. Substitution is used when one of the equations is easy to solve for one of the variables. Or perhaps one or both equations, it's already solved for one of the variables when it's given to you. It already says y equals something. Or it already says x equals something. That's a good time to use substitution. Again, there are 5 steps to substitution. I'm just going to go over them here quick. And you solve for one variable in at least one of the equations. If you need to, it might already be there. Then substitute that resultant expression into the other equation for that variable that you've isolated. Then solve that equation, this new equation that you have, to get the value of the one variable that is in that equation. So you've solved for the first variable. Then take that first variable and substitute it back into one of the original equations and solve for the second variable. All right, then you can write the values as an ordered pair. Your answer is an ordered pair, an x, y. It's a point. All right? For example 1, let's solve the systems of equations. They both say y equals, so they must equal each other. And that's what they do right here. 2x plus 5 must equal x plus 3 because they both equal y. All right? Now we have an equation with only x, so we can solve that for x and get negative 2. Then plug negative 2 back into one of the original equations and find out what y is. Well, it turns out y is 1. All right, we'll just double check into the other equation. Use negative 2 and 1. Again, put negative 2 where x is and 1 where y is. Just plug it in here and see. And sure enough, it works. All right? Just a couple things. Sometimes when you're solving the systems of equations, all the variables become eliminated. They eliminate each other. All right, when that happens, the equation you're left with, if it's false, then the lines are parallel and there is no solution. All right, here's an example of it right here. And when I substitute in the value for x, this becomes y minus y. The y's disappear then too. We end up with 3 equals 7. Well, that's not true. 3 does not equal 7. So there is no solution. All right, those are the parallel lines that never intersect. All right, however, you might, as you're trying to solve the systems of equations, again, the variables get eliminated, like this one right here, 6x minus 6x. It disappears. And you're left with 24 equals 24. All right, that means there's infinite solutions. Okay, we talked about that yesterday. Those are the same line. These two right here are the same line. There's one on top of each other. So there's infinite solutions. Again, just to review, these are the 5 steps to substitution. You're going to need that for the warm-up, I got a feeling. You're going to need that for something in there. All right? Solve the equation for one variable, substitute it in, then solve that equation. And once you get the solution to one of the variables, you've evaluated one variable. Plug it back into one of the original equations to get the other variable. And then just check your answer to make sure. Check with the other solution to make sure that your answer works. All right, that's it. Y'all can look at the homework check. We'll look at it in class 2. Yep, the warm-up right there. What are the 5 steps to solving a systems of linear equations using substitution? All right, we'll practice it. All right, thanks. That's it.